Okay, guys, let's look at our question of the day today. So we have not looked at a 3-step reaction mechanism yet, but we're going to just work through it the same way that we would. In this one, and I gave this hint in the question of the day, step 3 is not actually important. It's fast step, it's at the end, and it's not at equilibrium. So we can't really use it to help us solve. And since it's a fast step, it's not rate determining. So right now, looking at this, I've got a fast and then a slow. So I know that the slow is my rate determining step, which means it's going to be kind of the most important of all the steps. Rate determine, I spelled that wrong. Rate determining, I'm missing an ing here, ing. Okay. So let's work through the questions. What is the intermediate molecule and what is the overall equation for this reaction? I'm going to do those two together because when I cross things out, that helps me find my intermediates. So I've got 2 NOs in the reactants and I don't see that anywhere else. So I'm going to bring that down. Okay. Let's see, I have H2O2 in the products and in the reactant, so those cancel. So it was made in the first reaction, used up in the second. That means it's an intermediate. Okay, let's see, let's keep going. So I have H2 in the reactants. I see another one down here, but I don't see one in the products. So 2 H2s. Okay, and then N2. Let's see, I made one in step 2 and then I used it in step 3. So that is also an intermediate. And then I'm left with an N2 and 2 H2Os. Okay, so that is my overall reaction. And the things that canceled out are my intermediates. So those kind of work together. So now I need to know the overall rate law for this 3-step reaction. So when I look at this problem, I'm going to use the slow step to get started first. So I'm going to, since it's an elementary process, write my rate law based off of the balanced equation. So rate is equal to K. And I'm going to say K2 since it's the second reaction. And then the concentration of my H2O2 and the concentration of my H2. Okay, so this would be my rate law if it didn't include the intermediate. So remember, rate laws cannot include the intermediate. It is there for too short of a time. I cannot record that concentration or detect that concentration. So I need to get rid of that H2O2. So to do that, I'm going to use step 1 up here. So I am going to write inequality for the forward and the reverse reactions because I know when they're at equilibrium, they're equal to each other. So I see that I've got 2 NOs, so it's going to be K1 because it's the step 1 forward reaction, and then NO squared because of my coefficient of 2. And this is just for an elementary reaction, okay? And that's going to be equal to my reverse. So it's going to be K minus 1. So it's step 1, but it's in the reverse. And that is H2O2. Okay, H2O2 is what I'm trying to get by itself to plug in. So I'm going to divide by the K minus 1. Cancels here. And so I'm going to plug this whole piece into my rate law down here. So I end up with the rate equals K2, K1 over K minus 1, NO squared, and then don't forget that H2. Okay. Before I write my final answer, I'm going to combine all those K's to make one rate constant. So my final answer is the rate is equal to K for the overall reaction, NO squared, H2. So it is second order NO and first order H2.